So this is the question of 2018 May June paper 1-3, and the question number is 28. So it is 28. It says that a particle having mass m and a charge plus q enters a uniform electric field with a speed v. Yes. Initially the particle is traveling at right angles to the electric field, so that means the electric field is somewhat like this and the particle is going like this, so that means the angle here is equal to 90 degree. During its movement through the field, the particle is deflected through a distance d as shown here, so the deflection. Now we have second particle of mass 2m, so instead of m it is 2m, charge is same and velocity is same, enters the electric field along the same path. So what is the distance through which this particle is deflected? So we have to find the new deflection here. So let's first find the expression for the deflection exactly. So this deflection is the distance traveled in this direction, which is the direction along the force here. So this is the direction of the force, electric force on the particle. So this is the direction of the force. So what you can do here is this deflection y is equal to, so let's say we have the equation y equal to ut plus 1 by 2 at square. So u is the initial velocity in this direction, a is the acceleration in this direction. So here y equal to d, so d should be equal to the initial velocity in this direction is 0 because it is traveling in this direction, and when I consider this direction it is 90 degrees, so that's why the velocity in this direction initially is 0. So it should be equal to 0 into t plus 1 by 2 a into t square, that's equal to 1 by 2 a t square. Now the acceleration in this direction should be equal to 1 by 2 force in this direction by mass, and then the t is equal to I express this time in terms of the displacement here, displacement and the velocity here, so it is x by v square. So where x is the displacement in this direction and v is also this velocity, and the velocity in this direction is also v, and this velocity does not change. It doesn't change because there is no force in this direction. The only force is in this direction where the velocity changes, but since there is no force in this direction, this velocity does not change. So we have equal to 1 by 2, this F is equal to Q into electric field strength E by M x square by V square. Now the new deflection will be equal to d nu will be equal to 1 by 2, it's okay. Charge is the same thing here, charge is same, and the electric field strength is also same, it is E by mass. Now initially it was m and now it is twice m, so it is twice m. Displacement it is same, x square, and v also it is same, so it is v square. Now this thing becomes, this 2 comes out, so 1 by 2 into 1 by 2 q by E by m, then x square by v square. So this whole term is equal to this, so that's why, so we have this d nu is equal to 1 by 2 into d, 1 by 2 into d, so it's the half of the deflection compared to the previous one. So the answer choice will be B, which is correct.